Imagine for a moment that you are looking up at the night sky. You see the familiar glow of the moon, the distant twinkle of stars, and maybe even the faint smudge of the Milky Way galaxy stretching across the darkness. It all seems so permanent, so vast, and honestly so incredibly stable. The laws of physics that govern these celestial bodies have worked flawlessly for billions of years, allowing galaxies to form, stars to ignite, and life to emerge on at least one small blue planet. But what if that assumption is wrong? What if the stability we take for granted is just a temporary state of being? This isn't a question from science fiction or a philosophical thought experiment. It comes directly from the strange and wonderful world of theoretical physics. Some of our best theories about the fundamental nature of reality suggest a pretty startling possibility. They hint that the universe might not be as stable as it appears. In fact, it could be balanced on a knife's edge, vulnerable to a sudden and catastrophic change. This change wouldn't be like a supernova explosion or an asteroid impact. It would be something far more fundamental, an event that could rewrite the very laws of physics themselves, erasing everything we know and love in the blink of an eye, without any warning whatsoever. The idea is both terrifying and fascinating. It forces us to confront the true scale of the cosmos and our place within it. We often think of cosmic threats as external things, dangers from out there in space, heading our way. But this particular threat isn't lurking in the darkness between the stars. Instead, it might be woven into the very fabric of space and time itself. It's a hidden vulnerability, a cosmic secret that has been with us since the Big Bang. To understand this cosmic fragility, we need to think about the universe in a new way. We often picture space as an empty stage, a void where things happen, but according to quantum field theory, that's not quite right. Space isn't empty at all. It's filled with invisible energy fields like the Higgs field, which gives particles their mass. These fields permeate every cubic centimeter of the cosmos, even in the emptiest vacuum of deep space. They are the fundamental bedrock of reality, the silent architects of the physical laws that govern everything from the falling of an apple to the burning of a star. These fields, like everything in the quantum world, want to be in their lowest possible energy state. You can think of it like a ball rolling down a hill. The ball will naturally roll to the bottom, where it has the least amount of potential energy and is most stable. Physicists call this lowest energy state the true vacuum. It's the ultimate ground state for the universe, a state of perfect stability. For a long time, we assumed that our universe and its fields were already in this true vacuum state. But what if we're not at the bottom? What if our universe is like a ball resting in a small dip partway down the hill, not in the deepest valley? This state is known as a false vacuum. From our perspective inside this dip, everything seems perfectly stable. The ball isn't rolling. The laws of physics are consistent and reliable. However, a deeper, more stable state, the true vacuum, exists just over the edge of our little valley. The universe is stable, but only for now. It is in a precarious, temporary state of being. So, if our universe is perched precariously in a false vacuum, how does it make the jump to the true vacuum? The process is called vacuum decay, and it's a pure consequence of the strange rules of quantum mechanics. In the quantum realm, particles and fields can do something that seems impossible. They can cheat. They can tunnel directly through an energy barrier without having to go over it. According to the theory, a random quantum fluctuation somewhere in the cosmos could be enough to push a tiny patch of space over the edge and into the true vacuum state. This event would create a microscopic bubble of the true vacuum. Inside this bubble, the fundamental properties of the universe would be radically different. This bubble wouldn't just sit there. Once formed, it would begin to expand outwards in all directions at the speed of light. As the wall of this bubble swept through space, it would convert everything from the old false vacuum into the new true vacuum. It would be the ultimate phase transition, far more dramatic than water turning to ice. The very nature of matter and energy would be rewritten. Atoms would likely cease to exist. Stars, planets, and galaxies would be instantly annihilated and replaced by whatever the new laws of physics in the true vacuum dictated. It would be a complete and total reset of reality. The most terrifying part of this scenario is that we would have absolutely no warning. Because the bubble wall expands at the speed of light, no information about its approach could ever reach us ahead of time. One moment you could be sipping your morning coffee, and the next, you and the entire observable universe would simply be gone. To truly grasp the idea of vacuum decay, we first need to journey into the bizarre and counterintuitive realm of the quantum world. When we look around us, we see a world of solid objects, chairs, tables, planets, and stars. However, modern physics tells us that this solid world is just an illusion. Underneath it all, at the most fundamental level, reality is made of something much stranger and more ethereal. It is built not from tiny, solid balls of matter, but from vast, invisible entities known as quantum fields. These fields are the true building blocks of the universe. What we perceive as particles, like the electrons in the atoms of your body or the photons of light hitting your screen, are not separate little things. They are simply ripples or localized vibrations in their respective fields. In everyday language, a vacuum is simply a space with nothing in it. But in quantum field theory, the definition is much more specific. A vacuum isn't the absence of everything. It's actually the lowest possible energy state of a quantum field. However, lowest possible energy doesn't necessarily mean zero energy. According to the strange rules of quantum mechanics, a quantum field can never be perfectly still. Even in the emptiest space, fields are constantly fizzing with tiny, fleeting fluctuations, a sea of virtual particles that pop in and out of existence in an instant. The crucial question then is this: is the floor we are standing on the lowest possible floor? Is the vacuum state of our universe the true ground state? Or is there another, lower energy state that the universe could potentially fall into? Let us imagine for a moment that the unthinkable has happened. Somewhere in the unfathomable depths of the cosmos, maybe in a galaxy billions of light years away, a single, random quantum event has occurred. A tiny patch of the Higgs field has tunneled through the energy barrier, creating a microscopic seed of the true vacuum. From this infinitesimal point, a bubble of a new reality is born, and it immediately begins to expand. This isn't a slow, creeping change. It is an onslaught of cosmic proportions, moving at the ultimate speed limit of the universe. Think of it as a perfectly spherical tidal wave of physical law transformation, consuming everything in its path. It doesn't slow down, it doesn't weaken, and it cannot be stopped. Nothing in our universe can stand against it, because the bubble itself represents a more fundamental, more stable state of being. It's not so much destroying our universe as it is overwriting it, like a computer formatting a hard drive and installing a new alien operating system over the old one. What would actually happen at the precise moment the bubble wall passed over you? The fundamental constants of nature that underpin our reality would instantly change. All matter would instantly disintegrate into a hot soup of elementary particles, or perhaps into entirely new forms of matter we can't even conceive of. This new universe inside the bubble would be a new creation, but it would likely be a sterile and uninteresting one. It would be a cosmos, reset to a more stable but also more boring ground state, with all the wonder and complexity of our current existence erased forever. So, what would you see? What would you feel? The answer is perhaps the most unsettling aspect of the entire vacuum decay scenario. Absolutely nothing. Let's say the vacuum decay event happened in the Alpha Centauri star system, just over 4 light years away. For 4 years, the bubble would expand through space, completely invisible and undetectable to us on Earth. Then one day the bubble wall would arrive. In the exact same instant that the light from the event itself would reach our telescopes, the wall would pass through our solar system, through the Earth, and through you. There would be no flash of light, no sound, no sensation of being torn apart. From your perspective, existence would simply cease, without any transition whatsoever. It is the definition of instantaneous oblivion. After exploring the terrifying, instantaneous nature of vacuum decay, it's only natural to feel a sense of cosmic unease. However, before you start looking over your shoulder for an expanding bubble of doom, it is crucial to place this possibility into its proper context. The first and most important piece of good news is that even if our universe is in a false vacuum, the chances of it decaying are believed to be extraordinarily, incomprehensibly small. The estimates for how long we might have until a random quantum fluctuation triggers the end are not in the thousands or millions of years. They are in the billions, trillions, or even quadrillions of years. Some calculations suggest the half-life of our vacuum is a number so large it would require hundreds of zeros to write out. To put this into perspective, our universe is currently about 13.8 billion years old. The predicted lifetime of our false vacuum dwarfs all of these immense timescales. It's like worrying about your house being eroded by a single drop of rain once every trillion years. Another powerful argument against losing sleep over vacuum decay is the universe we see all around us. We can look out into the cosmos with our telescopes and observe galaxies that are billions of light years away. When we look at a galaxy that is 10 billion light years distant, we're seeing it as it was 10 billion years ago. This means we have a direct observational window into the past, allowing us to see that the universe has been stable and governed by the same laws of physics for a very, very long time. The fact that we see a universe that looks remarkably uniform in all directions, filled with galaxies that have been evolving peacefully for billions of years, is strong evidence for its stability. Furthermore, even nature's most powerful cosmic events, like supernova explosions or the merging of neutron stars, do not seem to have triggered a vacuum decay event that we can detect. The universe has been running its own high-energy experiments for billions of years, and so far it has remained intact. Ultimately, the question of vacuum decay should be viewed not as a source of existential dread, but as a thrilling scientific puzzle. It represents a frontier of human knowledge where our most advanced theories about cosmology and particle physics intersect. The possibility that our universe is metastable is a direct prediction arising from the standard model of particle physics. Therefore, investigating this possibility is a crucial way for us to test the limits of our own understanding and to probe the deepest nature of reality. It's a problem for physicists to solve, not for people to fear. The overwhelming consensus from the scientific community is a resounding no to worry. The probability is astronomically low, the timescales are incomprehensibly long, and the entire concept is based on theories that are still being tested and refined. Contemplating the idea of vacuum decay offers us something incredibly valuable: a profound sense of cosmic humility. In our daily lives, we're the masters of our small domains. We build cities, create art, and develop technologies that give us an illusion of control over our environment. But the vacuum decay hypothesis serves as a powerful reminder of how little we truly know, and how vast the universe is compared to our comprehension. It forces us to confront the reality that we are inhabitants of a cosmos whose fundamental rules we are only just beginning to decipher. This perspective can be liberating. By accepting that we are not the all-powerful masters of the universe, we are freed to simply be what we are, curious explorers on an incredible journey of discovery. We are a part of this vast, mysterious cosmos, lucky enough to have evolved the consciousness to appreciate its beauty and ponder its secrets. The idea of a potentially unstable universe naturally leads us to question our purpose. If everything we know and love could be erased in an instant by a random quantum event, what is the point of it all? This is not really a new question for humanity. We've always sought meaning in the face of our own mortality. The answer, perhaps, is that meaning is not something that's given to us by the universe, but something we create for ourselves. The cosmos may be indifferent to our existence, but that indifference does not have to be our own. The fact that we are here at all is an astonishingly rare and precious outcome of cosmic evolution. The potential fragility of the universe doesn't invalidate our experiences, it makes them infinitely more valuable. A beautiful symphony is no less beautiful because it eventually ends. A life well lived is no less meaningful because it is finite. In the end, what should be our takeaway from this journey to the edge of cosmic annihilation? Should we live in fear of a silent, instantaneous end? Absolutely not. Instead, we should embrace the profound sense of wonder that such ideas evoke. The fact that we can even conceive of questions about the ultimate stability of the universe is a testament to the incredible power of human curiosity and intellect. The study of concepts like vacuum decay connects us directly to the grandest traditions of human thought. From the ancient philosophers who first gazed at the heavens and asked, "What is all this?" to the modern physicists scribbling equations on a whiteboard, we are part of an unbroken chain of inquiry. This sense of wonder is a powerful antidote to fear. When we look at the universe through the lens of science, we see not a terrifying void, but a place of immense beauty and intricate order. We see galaxies dancing in a cosmic ballet that has unfolded over billions of years. We have journeyed together to the very edge of existence, peering into the abyss of a potential cosmic catastrophe. We have explored the strange quantum world and imagined the birth of a bubble of new reality. The concept of vacuum decay is one of the most profound and unsettling ideas to emerge from modern science. Yet, as we stand on this theoretical precipice, we must remember the context. The timescales involved are so mind-bogglingly vast that they render the threat all but irrelevant to us. The precipice is there, but it is likely trillions of years away. So, the next time you look up at the night sky, remember the silent, invisible fields that fill the space between the stars. But do not feel fear. Instead, feel a sense of profound connection to the grand, unfolding story of the cosmos. The universe is not a threat. It is an invitation to wonder, to explore, and to marvel at the mystery of it all. What, then, is the lasting value of contemplating such a remote possibility? The true power of the vacuum decay hypothesis lies not in the answer, but in the question itself. Asking, could the universe spontaneously destroy itself, is an act of supreme curiosity that pushes the boundaries of our imagination. Furthermore, these questions have a unifying effect on humanity. When we contemplate the ultimate fate of the entire universe, our terrestrial disputes seem to shrink in significance. We are simply humanity, looking out into the darkness and wondering together. In the end, our exploration of vacuum decay leaves us with an invitation from the cosmos itself to participate in its story as active, conscious observers. The universe offers us the profound privilege of witnessing its majesty and trying to understand its workings. We should accept this invitation not with fear, but with excitement and wonder. The universe is a place of wonder, and we are incredibly fortunate to be a part of it. And that is an invitation we should all gratefully accept.